Welcome everyone. In the previous video I explained that how to plot the output characteristic of the transistor so that we can determine the Q point and we can plot the load line also. So it was actually the output characteristic. Now we can see that I have plotted the DC load line. This is the Q point where the specified supplied voltage VCC is 9 volt. This VCC cannot be changed because it is a specified supplied voltage. Now, if VCC is 9 volt, then you know that to work properly for an amplifier, the Q point must be in the middle of the load line. So VCE must be 4.5 volt when IDC, or the quiescent collector current, capital I suffix capital C, will be 5 milliamperes and the IC max will be 10 milliamperes. Now as you know that IC max is equals to VCC by RC plus RE, so you can find RC plus RE equals to 900 ohms. Now suppose if the question is given like that, you must have the gain of the amplifier 5, gain equals to 5. It means RC by RE equals to 5, which means RC equals to 5 times of RE. Now if you apply KVL at the output terminal, these are the parameters for the output terminal. The voltage across RC plus the voltage across collector and emitter, which is VCE, and plus the voltage across RE is equals to the 9 volt. So we can write VCC equals to VCE plus IC RC plus IE RE. As we know this is 9 volt, VCE must be 4.5 volts, IC and IE are nearly equals to same because IB is respectively very small. So we can take IC as common and we can write RC plus RE. So 4.5 equals to IC RC plus RE. As you know that IC is the quiescent collector current, which is 5 milliamperes. So 4.5 divided by 5 milliamperes equals to, put RC equals to R 5 RE, means here it is 6 RE. So RE equals to 150 ohms and RC equals to 750 ohms. Let us put the values in the circuit. This is 0.75K this is 1.5k, 0.15k. Now when you have these values, then you must have to find out this R2 and R1 also. Now to find out R2 and R1, you must have to apply KVL in this point. In this point means the voltage across this, which is 0.7, and the voltage across this will be the voltage across here. Means VBE plus IERE equals to I into R2. So VBE, you know, 0.7 volt plus IC into RE. So IC into RE means the voltage drop will be 0.750 equals to, now I2 IR2. You don't know I, what is the value of I. You also don't know the value of R2. So let I be like I, but R2 is actually having some value. The formula for it is like this, that the value of R2 must be smaller than the 10 times of value of RE, or it can be equal to also it. So let me take it 1 kilo ohms because it is smaller than the 10 times of RE, and if R2 is 1 kilo ohms, then you can find out I1. So I equals to 1.45 milliamps. Now you have found out this value, which is I. Now if we think or assume that IB is very small, it is actually very small, then the current flowing here is equals to here. Here the potential drop is 9, and here the potential drop is 1.45. So the current across here we know, and we also know the potential drop across R1, which is 9 minus 1.45, means R1 into I equals to 9 minus 1.45. We know the value of I also. So 9 minus 1.45 means it is 7.55, and it will be divided by 1.45 milliamps. So R1 equals to 5207 ohms. Let me put this value, 5. So we have find out all the values what we had need. Now we will apply some supply voltage, and yes, of course, before that we must have to give some blocking capacitors. I will later on tell you, in the next part I will tell you that what will be the value of these capacitors and how to determine them, and also I will tell you how to choose the bypass capacitor. Okay, let us put the sine wave. For the output purpose, let me take a resistance here. Let me choose the amplitude first as 100 millivolts. Okay. Let me choose the frequency as 1 kHz. VC should be 0. Now here I put this thing. Okay, before it, let me go for the simulation profile first. Here it is, the profile. Let us run it for 10 milliseconds. Okay, you can see it is 100 millivolts sine wave. It is actually coming. So it's totally nice. Let me make it a bit small. Yes, now it is clear. Now we will take the output. Yes. Okay. I actually forgot to mention you people that depending on the frequency, this resistance of the capacitance also changes. You know it. So you have to large capacitance so that it will not act as a resistance across these terminals, both of them terminals. So instead of 1N, I have chosen 16 mu farads. Okay, now the supplied voltage and the other things are same. Let us take the output. Okay, as you can see, this is the 100 millivolts input signal, and this is the 250 millivolts, or nearly about 300 millivolts output signal. Now you may think that the gain must be 5. So how it is coming 2.5 or 3? Nothing, you just have to change the resistance across here, which is taking the value, sorry, the voltage, and if you run it again, you will find out the graph will be like this. Now it is nearly 500 millivolts, means the gain is nearly about 500, sorry, 5. But here if you change the signal amplitude like 200 millivolts, sorry, 500 millivolts, you will have the output like this. So it is coming 2.5 because 500 into 5, it is 2500 millivolts, means 2.5. But whenever you are going to apply 1 volt here, you will find this type of distortions. The reason behind it is actually when the output signal is coming 5 volt, it is coming in this manner. Means once the VCE is going down for the negative half cycle of the 5 volt amplitude output, and it is coming again 9.5 for the positive half cycle of the output, means the VCE actually going to the saturation region for the negative half cycle, because it is in 4.5 and it is going out of 9 for the positive half cycle because it is coming 9.5. That's why it is that's why the distortion is coming. What is actually happening that in the saturation region no amplification can be done, and the output also cannot be more than VCC. Now if VCE is 4.5, then minus 5 from 4.5 will be minus 1.5, sorry, minus 0.5, which is beyond the saturation region. And for the positive half cycle, 5 plus 4.5 means it is 9.5, which is also beyond the VCC. So the distortion is coming. But if you apply 600 millivolts or suppose 900 millivolts, then you will find out this type of graph. And if you apply 800, you will find this graph. Well, in the next video I will show you people how to adjust the value of this capacitance and also add the bypass capacitance. Thank you.